For continuous air and water barriers on your next build, choose Zip System Ceiling Solutions. Seal tough jobs in a flash.
Welcome to the UnBuild It podcast. I'm your host this week, Pete Yost. I'm here with my all-time buddies, Steve Basic, the architect.
Hello.
And handsome Jake, the builder.
Hello.
And so we're doing this series on framing. We started with the floor, we moved up to the walls, and now we're going to work on the roof. So I think the underlying question is, what's all about with roofs, right? That's our underlying question. So, and Steve, when you go to lay out a roof design, what rises to the top? Oh, sorry, I couldn't resist that.
It's unbelievable. I tell people they don't believe me.
Let me tell you what the first thing I think when I get a set of
Why don't you tell me
plans.
the first thing I think?
I can't wait.
The first thing I think.
Where's
you.
water going to go?
Where's the water gonna go?
Nice.
That's not nice.
Is that the way that you look at
No,
a roof
definitely
design?
not.
Okay, then what is your
Because
criteria?
I get to the point where I know where water's going. I don't have to ask that question.
Well, okay, I'm going to push on this one because the very first thing that I look at in a plan set is the roof plan. Because then I know how bulk water is being managed up at that line. And I know that
Really? That's
you're
not true.
we're in
That's
agreement.
really not true. Because the first thing you look at is the title sheet. Because you need to find out where the roof plan is.
No, Pete's like
No,
me.
I
He just
just
flips
flip
until he
through.
finds it. That's what I do every single time.
See, your problem is you think much more highly of us than we deserve.
No, his problem is he's an architect. He thinks people read the freaking title sheet. Quit making a title sheet. Nobody's looking at that first page.
You will never get another title sheet on a set of drawings.
One of the
People are going to
first-
say, "Where's the residence?" I'm going to say, "I don't know, Pete. Jake said no title sheets."
One of the very first things I learned from you was if you're going to simplify anything, simplify the roof. And many of your buildings have incredibly simple roof lines.
Yes, because why complicate things? If you want it to be around a while, then keep it simple. Where does the water go? All those questions need to be answered, certainly. It's one of the more dangerous things is to start pushing water left and right over your head.
And you have that great slide where you show how simple the roof plan is on your current home. And then, look what people have done to it over the years. And remember that series you did where you started off with a real simple cape design, and then over on the right, it's just
It's
like
got four
all hell's
dormers and
broken.
2 or 3
broken.
L's, but that's what happens.
Which is actually a really good point because water management 150 years ago, it was the same type of water hitting a building in the same way.
Right.
And you generally didn't have major roof problems where valleys led to hidden structures to ponding where we had to have flat roofing and things. But if you look at a historical house, for the most part, we kind of all agree that things were pretty and they were simple. And yet, for some reason, for your house today to be architecturally interesting and significant, it must be McMansion roofed out the wazoo. And now
Clients tend to want to provide upward pressure in areas of higher risk, right? Like, oh, can we add 3 dormers there? Can we put them nice
Why?
and tight together and kind of thing?
So better places to get the geometrical complexity that our eyes want than roofs, right, generally?
Yeah, there's a lot of ways to get it, certainly. I mean, roofs do play a role, especially if you're doing, taller pitched roofs, because then you potentially have a whole lot of roof that if there's a way to break down the scale, maybe you pop through it, maybe you do a dormer here or a dormer there. But it can certainly, when you drive around and look at houses, you can certainly see roofs run amok.
I know you guys have heard this before, but the house that we live in is a 4-gabled gambrel.
Yeah, I think I've heard that once or twice.
And I generally, when I'm teaching a bunch of builders, I'll say, okay, how many of you here have done framing? And, most of the hands go up and you say, how many of you have framed a 4-gabled gambrel?
Well,
And almost never does anybody
it
raise
sounds a
their
lot
hand.
more complicated than it is, because the reality is it's a pretty simple roof.
It's wicked hard to frame because you don't start with a reference point, right? You've got there's nothing you can start with in terms of the ridge. because there's 4 gables and they're all about the same size. You know, there's nothing to start off of.
If I was to build that now, you would build the wall, hold it in 2 feet. You'd put in the long, like 20 and 12 rafter, right? And then you would build that wall as the L. So you'd have 4 L's.
That's way more complicated than just building an A-frame roof, right?
Well, it's more complicated than building an A-frame roof, but it's a lot less complicated than building like a double L roof with a couple bump outs and 5 dormers is my point.
Yeah.
Because your roof, your roof has 2 rafters in it.
4, two on each side, because I got a pitch change.
The pattern is 2 rafters.
Right. I'm not worried about the pattern. I'm worried about getting them together at the ridge.
No, I get that.
And having
but
all
I'm
4
saying
gables
from a
line up.
complication standpoint, I only have to figure out 2 rafters.
Well, let me explain to you that the people who did the framing in our house were the masons who did this kick-ass job on the foundation in the first floor, which is split-face architectural block. When they got up and tried to frame a 4-gabled gambrel as masons, I paid for that through the nose in terms of how just incredibly complicated the framing was up at the top.
What year was your house built?
1907.
I mean, gambrels are tough roofs, even if you build them today, because they're one of these roofs that really put you in a quandary of, am I inside or outside kind of thing.
Yeah, that's very true.
Because they have that inner wall that needs to carry the steep pitched section, and so now you're displacing your air barrier most likely to the inside face, and it's a question of like, what do I do from here?
Yeah.
It doesn't help that they're ugly too.
What's funny is that I had an architect who worked with me at the NHB Research Center, and he and his wife, who was an architect, bought a house in Baltimore. It was a 4-gable gambrel with a masonry base, and I said, that is the ugliest building I've ever seen. I would never buy a house like that. And I called him when we bought the house in Vermont. I said, hey, Eric, guess what house I bought? He said, you bought a stone or a masonry house, 4-gable gambrel? And I said, it's hard to get the massing right. It just looks weird.
I also don't like it when shingles feel like they're on the wall. And that's the way a gambrel has always felt for me.
When they're done right. So
welcome to gambrel talk with.
I guess so, yeah. Sorry.
When they're done right, I think they look very elegant. But I would say out of all the gambrels I've ever seen, probably about 25% of them were done. Proportionally correct,
right, yeah.
With the right pitches for the right spans, right dormer, right window selection, all of that, where you looked at it and go, that does look really nice.
I know exactly what you're saying.
And then there's some that you look at and go, what the hell were you thinking? Boy, did you miss the boat on that one.
What about the mansard roof then?
Mansard.
Mansard?
Mm-hmm. Mansard.
Well, then I've been saying it wrong.
Mansard.
I just learned that in real time.
It's Mansard. Mansard.
Those are... So how does it differ from the Georgian? Is the Georgian a type of mansard roof?
Well, Georgian is more of a house style.
As opposed to
opposed to a roof. But the Second Empire roof Second Empire style pretty much has the mansard roof to it. Like you live in the roofs. In New England, you see them a lot. Especially like coastal towns, like ship's captains and stuff like that. Old captains, those were the kind of houses of prominence because they had a 3rd floor. It's like, ooh, we have a 3rd floor on our house. It's tucked up under the roof. The problem is the mansard is really it's a real squatty gambrel, right?
With a turnout at the end.
Yeah,
right?
So it's like you still have that pretty steep lower pitched roof. It's just the upper pitched roof went from maybe a 5 and 12 to a 1 and 12 or something like that.
A little
so
cap.
It got really flat down.
All right, let's find our way back on track.
But so roof framing, when it comes to roof framing, it's interesting because I think there were pretty much 2 predominant, right? You either did a cut roof, which guys would call it, or a stick roof, which is, 2x10s, 2x12s, or in some locations, 2x8s, 2x6s, depending on where you go, or a truss roof. And lately, you're starting to see, again, with, people's desire to have these big open span type spaces, you're starting to see I-joists come into play as roof rafters. But remember, we were with a gentleman, we gave a talk, and he was out in Colorado saying that he doesn't like to use I-joists because they get moldy at the top. He was finding mold and rot issues at the top of the I-joist from bad ventilation and the OSB.
And the bad ventilation specific to the type
or,
of framing?
Or no, it was a hot roof using it, I believe, but moisture was accumulating at the top chord of the I-joist and pretty much rotting it out.
Because his OSB framing member is
the
more
OSB
susceptible
framing
than dimensional lumber.
Yeah, pretty much.
Which in reality has nothing to do with the framing materials. It has to do with the assembly.
It probably has more to do with the assembly than it does the framing materials and water management and vapor management and such. But I'm doing a house right now where predominant roof structure is going to be a parallel chord truss. So it's the I-joist, but it's basically a open web truss. We're just going to get them made as roof rafters. Which is pretty interesting because this house here is probably we have some spans where the trusses are probably running about 20, or the members are running about 26, 28 feet. So they're going to be like 18 inches deep, parallel chord trusses. So that should make for a pretty interesting frame.
Does anybody have a sense of when we could have switched from, mechanical fastening at the eave instead of these wicked big bird mouths? Bird mouths always seem to me to be sort of a strange creature to take a deep member and cut it down and then toenail it into the assembly.
Well, you're creating a bearing point though too, right?
Yeah.
I mean, that's the whole reason for it is the...
But when did it make sense, or did it ever make sense to switch and just have that bearing point be a mechanical fastener as opposed to a chunk of wood? Have you ever done a roof where it was solid sawn and there was nothing cut out for the eave junction?
No, because then you'd have to go to like a triple top plate, and it would have to be a low enough pitch to gain the slope all in the single member, right? So that if you did, it's probably in the order of like a 4 or a 5 and 12. If you go taller than that, now you're chamfering 2 plates instead of just 1, because you only have that 1.5 inches to deal with. Because you have to put some kind of wedge plate in there.
Got it.
If you used it without the bird's mouth. So the bird's mouth doesn't necessarily bother me. That's actually quite easy detail. Trying to think. There's the advanced framing that, it's kind of like floor framing. Roof trusses, I'm very comfortable 24 inches on center, like parallel chord trusses, 24 inches on center. But doing regular stick framing, we usually keep that to 16 inches on center. And that's
Why?
Just because of the spans for the most part and span rating. And if you go a little wider, you're probably going to want to go to a thicker deck. A thicker deck is a heavier deck, so things like that. The other thing to consider, as we forge forward that a lot of people don't, is the weight load of PV arrays. And, planning for that, so that making a home zero energy ready is also understanding that you need to design your roof system to be able to take that load in the future.
In the city limits of Columbia, you also have to have 600 square feet. I think it's 600. I might be wrong. It might be less than that, of uninterrupted south-facing roof for solar-ready requirements, which we had a home designed in 2017, maybe, right after this came into effect, that doesn't have a south-facing roof at all. And we went to the city and we said, hey, what are we supposed to do here? The code says that we have to have 6. And he said, no. It says if you have south-facing roof, it has to. And I was like, that is the dumbest thing in the history of the world. So all you have to do is just make it north-facing, and then you don't have to worry about it.
So if I put a bathroom on that one side with a roof faces south, it's got to have a 600 square foot roof on it.
Yeah. It's one of those poorly thought out.
Yeah.
If you accommodate solar, you have to accommodate solar.
Yeah,
I like
exactly.
that. I like that.
So let's go back to trusses for a minute, and let's just talk about what are the downsides to working with trusses. You got to order them.
You got to order them.
So there's a planning and potentially a material delay.
Very fixed dimension, right? So that your walls and everything have to be. But most of the time, you have an understanding of what your walls are going to be when the floor deck is down. So you can kind of set your plates, and then you can have the guys come and measure, and they can be building the trusses while you're framing the walls.
Mm-hmm. We have Truss Uplift.
We have Truss Uplift to deal with.
And if you don't know what Truss Uplift is, it's exactly what it sounds like. The bowing of the framing members upward or downward, the uplift caused by wind or whatever. And if you talk to your truss manufacturer and you say, well, what causes this? You know what they'll say? Well, we don't know. It just does it sometimes.
Really?
And it's like, you bastards.
I mean, truss uplift is the bottom cord, right, and its movement responding to the load that changes on the roof.
But they give you sometimes it just happens.
Because it seems to me that if you know that you're going to get increased load with, I guess, wind or snow, you're going to flex the triangle and the bottom cord's going to move.
Yeah.
Which tells me that the software parameters that they set for building their trusses are let's make them so that they barely pass. And when we have an extraordinary event that causes this, we'll go, well, we don't know why it did it. Because I'm certain that they could build them a little bit stronger and lessen the likelihood of it happening.
I don't know if you can, I mean, we were working on a roof there was a 58-foot span. And I think it was a 5 and 12 because we broke them into two pieces, so split down the ridge, so that they could be road transported because they were 14 feet tall. And one of the first things I did was go up into the attic space, because it was a flat roof being converted to a pitch roof, and I started to bind the bottom cords so that we could more easily, put down plywood and walk on those. And they happened to have a defective truss they caught in the quality process. So an engineer came out to the roof to look at the defective truss. He goes, "Who the hell pinned all these bottom cords down to the existing roof?" And I said, "I did that to stabilize them." He goes, "You don't understand how trusses work. If you bind that bottom cord, you're going to crack these trusses." I was like, "Holy crap, I better figure out how these trusses work."
Because then it can't do its
needs to move.
Lift thing in the
Yeah, and if you bind it, that you're not relieving the stress.
You're going to split the wood, or you're going to split the metal.
You're going to split the bottom cord, or pull out a plate or something. So that was a little scary.
So also I'm complaining about it, and I've had it happen once in my entire career. But
you had what happen?
Truss uplift that caused damage.
Yeah, we had one house. I mean, with Palo Duro Autistic Homes, I probably did, let's say 600. I would say 5,000 homes with them, and we had one noted problem of truss uplift. So
I think I understand
better
that.
than mine.
When you said they don't know why trufflets happen, you're talking about excessive uplift. I'm talking about you have to allow for the fact that it's going to reasonably move. Now I understand.
I thought it was due to the upper cord was cold and dry. The bottom cord was warm and wet. And so the expansion and contraction of the expansion of the bottom cord, the expansion of the top cord, or the bottom cord, contraction of the top cords made the trusses move so that there was upward bowing.
Interesting.
In the lower cord.
Because the engineer that came to the site said, especially trusses this big, they move a lot with snow load. In fact, it was a dry cleaning business, and we had a plumbing stack that went through, and he said, you better allow for like 4 or 5 inches of movement of that top cord.
Yeah, it ain't moving that much.
No? In a 58-foot span?
No, there's no way it's moving that much. Not 4 or 5 inches.
2 inches?
2 inches is probably a push.
Yeah. Anyway,
I'd say maybe
inch
a
and
half
3/4?
inch or
plenty of movement.
half inch or so maybe. But when you're talking about restrictions, I remember with Palo Duro, one of our constraints, if you were that at a 5 and 12, we couldn't make trusses any wider than 55 feet. because then we had to get special permit to haul them down
Yeah.
the road.
Yeah, that's
they're not gonna
exactly
mess
what
with that.
happened.
And they're not gonna, or we'd have to break them into two, and they didn't really like.
Yeah.
And we didn't. It's
a lot
interesting
more
that you
work.
broke yours vertically, because when we did have to break them, we would break it horizontally, and we'd get like a small crown piece.
Really?
Yeah.
That's the way we've done it.
So
Yeah,
the bottom
they were
gets
they were
You get a
wicked
funky
hard.
looking floor truss.
trapezoidal.
They were-
They'd have a trapezoidal bottom piece and then a small little gable truss that's
Yeah.
set up on top.
They were wicked hard to set. That's for sure. But
And the other thing with trusses is you do pretty much forfeit the attic space. I mean,
You can
they
order
make
box
attic
trusses.
You can get attic trusses, and you can get some of that space recovered.
But the one time I remember a project, I think it was a Building America project where we had the box trusses. Boy, it's really tough to get the continuity of the air barrier, translated across those. It was hard to get that airtight.
It is, but the way I would do it, if I'm going to go up there, I would sheathe the face of the attic truss and then frame a wall in front of it.
Oh, yeah. Why fight it?
Why fight it? Exactly.
That is really clever. I would never have thought about
Yeah,
that, but
the times
that
we've
seems
done it
so
where we
obvious.
finished it, we would just do that and then frame a 2x4 wall, stand it up in front of it.
Man,
and
note
then
to
you get a
self.
stud cavity.
Yeah.
So then the other opportunity is something I saw Randy Williams do, which we had on the podcast recently. They framed a little plenum, or they had the trusses ordered with
I have
a little,
a passive house that we're doing that on
okay,
right now.
little plenum in the bottom of the truss so that they had an HVAC chase
Oh.
underneath
Ours is
the
going to be
truss
more.
frame.
Ours is like, it's like
That's
10 or
Steve's.
12.
So the bottom cord just has a little jog up. So it's sort of the opposite of the box where you're making into your box. This is, yeah.
That way they
lifting the
could
Ours
they
is
could have
like
a flat
10 or
ceiling in the
10
end,
feet wide, I believe.
yeah,
And it's every truss across the.
which is going to be really hard to do stick framing.
Oh,
I mean,
yeah, that would
it's
be.
then you're trying to do a tray ceiling down a whole hallway or down the
that's
middle of the
essentially
house.
what you're doing.
Yeah.
Because then you can sheathe it.
But
for
that's
your
more
air
of a pain in the
barrier,
butt.
And then you just put in some 2x4 ceiling joists.
Yeah.
After the ductwork and stuff goes, and that works. But let's talk. Those were we were talking about the cons of trusses. Let's talk about some of the pros of trusses.
Span.
Span is easy because you can go wall to wall and go 50 feet.
Speed.
Speed, but that's probably arguable against some good framers in a simple house.
Sure.
That's a hard one.
Simple to simple, at least.
Because there's building perspective in that one, right? Oh, no, I can cut a roof just as fast
Yeah.
as.
No, well, then I
put
have to pay
truss.
for a crane,
Yeah, and I got to pay.
or
for
I have to have a
crane and
lull
stuff.
on site.
The other nice thing about trusses is if you're building energy efficient houses, you can get that energy heel. So
Right.
Yeah, you can get the
that
heel height,
10,
whatever you call
10,
out.
12 inches, whatever it is. So there's that benefit.
So if somebody's doing a roof truss for a cathedral ceiling, or even I guess for a flat ceiling, do you recommend that the truss not include an overhang so you can wrap the air continuity layer of the roof plane down with the?
No, because most of the time, for me personally, I bring the air barrier in over the top plate and bring it into
So
the
then
house.
it's the bottom
Oh,
side.
that's right.
of the
Yeah, that's
scissor
your
truss.
detail does it. You're not worried about bringing that across.
But what we do is a lot of
He
times
said
like,
doo-doo.
you can get the trusses made so that if you had a flat soffit boxed eave, they can make that up in the factory.
Say that again. A flat
Flat
box.
soffit boxed eeve.
Yep.
Right. If
Okay.
you're boxing out the eave to a flat
Yep.
soffit.
Yep.
But we would tend to, or I tend to like getting the upper chords maybe about 2 or 4 inches longer than what's needed, because that way there you can snap a line and then just cut them after they're set, and you get a nice straight face.
And you can still get the depth of soffit and overhang that you were shooting for, rather than ordering them the size you want and then having to cut 3/4 off of one end
because they don't line up or
Right,
whatever. And then also with the bottom of the soffit, as much as you would like to believe that because they're factory built, their tolerances are very tight, it's a challenge. So we would rather just we would get the trusses, we cut them back to length. If we put on a rough fascia, so it's either a 2x4 or 2x6, it depends on what depth our fascia is, and then we'll bring a block back to box out the eave and give a flat soffit if we wanted to do that detail. And we do that on site because that's stuff that we can level and all.
What other pros do we have?
Nothing. We talked about ease.
There was a production builder down in Mid-Atlantic, just outside of Baltimore. They would build their trussed roofs on the ground,
Sheet them.
and sheet them, and so it was a huge liability reduction because they were essentially working on the roof.
There's
at
a bunch
grade,
of framers
and then
that do that.
they had a crane full time that was on the site. It just went down, and one day it would
Which-
pick up one
That
roof.
one
You
guy
could-
in the Midwest there, he does that all the time and then lifts it up with his lull and drops the front
Mark?
entry. And
Hendrickson?
no, Mark Erickson, he's done that too, but it's a Macatomus or whatever his name
Okay.
was.
But at that point, you could shingle it.
Well, no, they
Too, you know.
clad it. Yeah,
Which then
it
you're
just makes it
working-
heavier, but
Then you're working whatever the distance is from the ridge to eave off the ground rather than ridge plus the entire building
Right.
off the ground.
right.
I'll never forget, this was
God,
one of my...
that takes some effort, though. That'd scare me. I'd have a hard time with that the first time.
It's pretty wild to watch because the crane is, if you're cladding it, now I don't know, maybe you double the weight of the roof
Yeah.
by cladding it.
So this is a pretty cool story. And this was probably, I don't know, maybe the second job I ever did. This was many, many moons ago. And I didn't know enough to appreciate what he had done. But it was a hipped roof house. And we were putting in, and it had a 1-story on the side, and we were building that up to a 2nd story. And so the framer, he framed the walls, and then I was like, well, aren't you going to do the roof? He goes, no, not yet. And he went up there, and they sawzalled all of the hips on the hip portion of the roof, all the way back to where the common rafter started. They sawzalled it, and then they cut the sheathing. And I was like, what are you doing? He goes, oh, just watch. And so they did all of that, and then they went inside, and they took that section of hip roof and slid it down 14 feet. And then he filled in the
With more
space
commons.
With more commons.
Way
And
to
it's like-
avoid cutting the
It's like,
complicated
why
ones.
tear? He's like, why tear apart that whole hip roof and then
It's-
have to reframe it? I'll just slide it down the top plate.
Yeah.
Wow.
If you can keep it from spreading and getting wonky, why not?
Yeah, and then you just filled it
So-
in with common rafters. And
So did he do that for the whole? So you had to push down the whole hip. How hard was that to do?
it wasn't. I mean, he had a handful of guys. They moved it right
I would
down.
have thought that's really cool.
Walked it down, and I mean, he cut back some of the sheathing so you could tie it in and lap it and all of that stuff. But he said the most complicated part is cutting all the jacks and
Yeah.
all of that stuff. So
Yeah, if they did a good
he
job,
didn't
why
have
not
to do
keep
it?
it? That's very clever.
But you know, I always think to myself, like, kudos to some of these framers that you watch. You know, the Chevcons of the world and Erickson and these guys, because you see some of these roofs go up, and it's like you don't appreciate it until it's done, and you see the roof and go, holy crap, that was a lot of figuring out. And I don't care how good of a set of plans you have.
Yeah.
There's math and figuring out that those guys are doing that. As an architect, you have no idea what's going through their head.
And what's funny, you know, as a remodeler, having done a lot of different roofs, you know, we didn't do enough of hip and valleys that we could just crank them out. So we'd see guys that just framed, particularly roofs, and you think, man, but they're doing it all the time.
Oh, these guys are like beveling the top of the LVLs in the valley, so like the sheathing goes
right
right
over.
into, and yeah,
It's almost like
That might be a
cabinetry.
little much. That might not be needed.
no,
Those shingles are going to give it
they are,
a
but
dished effect anyway.
yeah, well,
I
they're
applaud the
using probably
effort, but-
cedar shingles and copper flashing in those valleys of that house. So, but
So that gets us to what are the pros of stick framing? Number one is complexity.
yeah, if it's a simple roof, it's very easy to adjust and run with. You develop the pattern, and you have a good guy down there cutting those patterns and tossing them up, and guys nailing them off. It is pretty simple. You get a somewhat usable attic or 3rd floor out of it, or 2nd floor, depending if it's a 1-story ranch.
time-wise, there's, and I apologize, I think his Instagram is Roof Slayer. He cuts the entire roof package in a factory or in a barn, bundles it together, hauls it out to the job, and they put it up. So there's no cutting on
Yeah,
site.
Erickson used to do that.
Because they
Like,
know
That makes a
what
lot
it
of
is.
sense.
you would just see the wood just stacked out on the job site, and it's like, yeah, I cut the roof yesterday, and it's just like the whole roof is just stacked there.
Yeah.
The
But I
math
get-
doesn't lie.
No, it's like once you get it figured out, you just need to understand what that kind of stepping increment is, and then you just cut it, which.
So when you do it, sorry to go back to truss in terms of a disadvantage, but when we did that roof that had the 58-foot run and 14 feet high, we had to build a whole rack system from ground level to hold the trusses vertical on the starting gable end, because until you get enough of the roof up, if the wind comes along, there are plenty of places where it just had collapsed. It took us a full day to build the rig just to set the first truss.
Yeah, they make spacers now that are like you can nail it to truss, and awesome framers Tom from Oregon. He's always
so there's a technique so you don't have to
it's
worry.
like a plastic bar. You can buy a box of them, put it down, and you just nail it, and it locks in the trusses together. So the minute you put two up, you can lock them together so they work in unison.
Huh.
So they're like these little strut systems
Interesting.
to interlace the
So
trusses.
you're
and
X-bracing
stuff.
truss 1 and 2, and then everything
So you already
else.
have what you need with the first two
Yeah,
set
they all
trusses.
lean on that
Yeah.
kind of X brace or whatever. But
Because until the sheeting goes on, you don't have that. I got you. Okay.
you know what I think is crazy though? It's like you go, I think it's Texas. They do cut roofs for these massive roofs.
I was going to
And you
say,
go upstairs and there's all these kind of diagonal struts everywhere that are just grabbing this valley,
it just screams trusses, but they're doing it with solids on.
Yeah, and
That-
it's
that-
like, just run a strut from the valley there down to that corner of the bearing wall.
It's the hi-hat roofs that you look at and you think, God, they're solid sawn framing those?
Yeah,
There's a lot of wood up there.
and
Do you think we hand cut so many roofs because carpenters are worried they're going to lose their jobs to a truss plant? Because I feel like I've talked to framers in the past that are just like, nah, we'd rather just go ahead and do the roof, so it's on us. And it's like, you not once have you asked for responsibility, and now you're asking for responsibility.
well, I mean, it's one of those things. I think the quality of your truss plant. We up by us, we had a truss plant. We did a couple projects, and Shoreline Builders spent a day or two planing the top of the trusses because they were that
Yikes.
far out.
Mm-hmm.
And it's like you can accept some things, but when things start getting above a 1/4 inch and 3/8 of an inch high or something, and it's like, yeah, you can send them back, but what are you going to do? Send them back and wait 3 weeks for the corrected trusses to come? So it's like, okay, how do I solve that here?
That's really interesting here because we always figured one of the reasons to go with trusses was, well, we know exactly how they're going to show up. They're going to show up stacked and they'll be exactly the same.
Yeah.
Yeah, that's funny.
Yeah, and our rule is if they show up and they're not going up that day, we got to cover them. They got to be covered. They got to be protected. They got to be up off the soil. Like, we
Yeah, how
gotta
many job
take care
sites
of 'em.
we've been in, and you just see them laying in a mud pile.
Yeah, like
When they're
somebody
doing
dro-
concrete work still,
Yeah,
or the concrete work's done and they're floor framing, and that they're just sitting in the mud for a week.
and
or
they
2
don't
weeks.
unload them carefully. They're usually a roll-off truck.
Mm-hmm.
So you cut the strap, tip the bed,
Yeah.
roll them right into the mud, and leave them there for a good month, and then pull them up and wonder why there's all these black spots all over them.
Okay, so are we saying that design constraints are what is dictating whether or not we're trussing or we're stick framing?
Well, I think it's very similar to the floor frame because the roof frame is doing the same job as the floor frame.
What is it
except
all
it's
about?
doing in a sloped fashion. But there's the budget constraints. There's the what am I doing in the attic? Do I want to live in the attic? Do I not want to live in the attic? Is it vented? Is it unvented?
Are there mechanicals going in the
up
attic?
there, or is it just a mechanical trough that's going up there? So there's a whole bunch of. Is there volume ceilings in the second floor or in that ceiling? That
So you're agreeing the constraints of the project are going to dictate what our choices are.
Yeah, I think so. I mean, my preference would be to do probably trusses. I mean, from an architect standpoint, it's much easier to lay out a roof with trusses. And
Well,
such.
and as a builder, I don't want people jerking around in the attic. There's no reason for you to be up there.
Well, it's one of those upward pressure things of, oh wow, look
Can
at
we
this
just
big volume of
capture this space?
Can I just like put a rec room up here, or 5 more bedrooms?
Sure. Do you want to pay to put a bedroom and a rec room up there? We can, but there's a cost.
And it's so typical in our area for a single story to put a half a story above to plan to finish that off later, or if it's a 2-story colonial to plan to put a half of a floor up there.
Is that the Vermonters' modesty where they don't want to say, yeah, we need another room, we don't want to spend that money, and then they go, oh, we'll do it. We'll just plan ahead, and then we're being thrifty rather than spending the extra money.
These
we're
are
being
the
thrifty.
same people that in the winter they divert their dryer load, into the basement so they don't give up those BTUs. So yeah, it's a pattern. Okay. But so if you're gonna do the half story, can we say that we're going to insulate and air seal along the roof plane and not try to follow the knee wall and this thing across?
The knee
because I've never gotten that tight.
That's certainly a challenge, and I would probably move to the roof plane.
Yeah.
With a hot roof scenario or outside insulation or something.
A vented over roof
or vented over or something.
But we're not talking about venting. We're talking about framing.
We're talking about the framing of it. One of the things I'm doing a project now where I wanted to look into was, can we do a SIPS roof? Just because of the span, the insulation, trying to stay away from spray foam, right? Because it would be really easy to go on this roof and just do a parallel core truss, do 4 or 5 inches of closed cell, fill the rest with cellulose, call it a day.
What kind of R value were you going to get with a SIPS roof?
That's the challenge.
Yes, because you want it to be
even at 12 inches at R4, it's still R50.
Not quite.
It's not even code
10,
at that
20,
point.
40, 60 rules.
Yeah.
So, yeah.
But it is an R50 that's fully continuous.
Yeah.
So the continuity factor is a major part of that equation that you don't get in a cavity cut roof system. So you do have that. But then even SIPs have, they have their constraints, and then you have to deal with the joints. And and if I did I've only done 2 SIPs roofs ever, and both of them we did an overframe vented assembly.
Yeah, as I said, when we worked with Dave Gothier with Winter Panel way back in when, he was moving towards, if you don't vent the panel roof, we'll void the warranty on the panel.
Yeah, we just did a 3/4 inch space.
Yep.
We still think it works fine, but yeah, we just laid down 1-bys and then resheathed the roof and then put the metal roof on top of that.
Yeah.
So.
Okay, so I think we're ready for Pete's resources.
Well, I hate to say it, but we're going to do a repeat resource.
Repeat of Pete's resource. Okay.
You didn't see that coming, did you? It's the same framing article that we used for the walls. Did we use it for the floor? I don't think we did, but yeah, it's the efficient framing article that we wrote.
Do you remember what it's called?
I'm pretty sure it's called efficient framing.
Okay. So if I Google.
Wood is good if used as
it
should be
used.
I forget.
The Amish were pretty sparse with their language, so it might not be grammatically correct, but
okay.
Used as it should.
That was roof framing. Let's say thank you for tuning in today. If you're watching on YouTube, we would love for you to leave a comment or like and subscribe. If you are listening, we would love for you to go to iTunes and leave a 5-star review. That helps other people organically find the podcast and us be able to grow the podcast, reach more people, and educate more people moving forward. I would like to say thank you, gentlemen, for joining me today.
Always a pleasure. And does it count if I go back and look at the YouTube over and over again?
Yes.
Oh, okay, good.
You got to do it from different locations with a different IP address, but you can sort that out.
Figure it out. Just buy a new computer every month.
There you go.
Watch it.
Have a good day.
Thanks, everybody.
Bye now.